event moderator. I just want to make sure the sound is working. So if you can hear me okay, please use the raise your hand option on the control panel on your right. So show of hands if you can hear me okay. Can you? Okay, wonderful. I see that you can hear me. Perfect. So today's event features 3 expert speakers. Joe Colantonio is a test architect for a Fortune 100 company. He's the author of the UFT API Testing Manifesto and the host of the podcast Test Talks, which you should definitely check out. Adam Kalmi is the co-founder and VP R&D of Applitools Automated Visual Testing. And Yaniv Bigger is the HP Live Network R&D Manager and Product Manager. Just before I hand over the mic to Adam, just some administrative stuff. Feel free to ask questions during the webinar. You can do that in the GoToWebinar control panel on your right. We will answer as many as possible at the Q&A session at the end. But even if we don't get to it after the webinar, we will email you an answer, so worthwhile asking. Code examples will be shown. We suggest minimizing the control panel so you can see the entire screen. Also, for optimal viewing experience, we recommend you close off any unnecessary apps running in the background. This webinar is recorded and will be made available for on-demand viewing. A link to it will be emailed to you once the recording is online. And also, if you encounter any technical issues, please send me a message in the chat room, also in the control panel, or email me, and I will try to take care of it as soon as possible. So let's kick off. Adam, the stage is yours.
Thank you, Adi. Hi, everyone, and thank you for joining us. We have a lot to cover today. In terms of the agenda, we'll start with an introduction to automated visual testing. We'll explain what visual testing is and why it should be automated. Next, Joe will give you a sneak preview to the much-awaited LeanFT, and we'll also show you how easy it is to implement a cross-browser visual test with Applitools Eyes and LeanFT. After that, we'll take a closer look at some of the unique features of Applitools Eyes that allow you to run automated visual tests at large scale, and also explain how automated visual testing fits in your testing and development lifecycle. After that, Yoav will show you how you can learn and get more information about LeanFT, Applitools Eyes, and much more with the HP Live Network. And as Adi mentioned, there will be time at the end to answer any questions that you may have. So let's get started. What is visual testing? Visual testing is a quality assurance activity aimed to verify that a graphical user interface appears correctly to users. This goes beyond the traditional functional testing that you're used to do with tools like UTP or Selenium, where you actually validate the functionality of the application through the UI. What we are focusing on here is making sure that the UI itself appears correctly to the end user. We want to make sure that each UI element appears in the right color, shape, position, and size, and that it does not overlap or hide any other UI element. This type of testing has become increasingly more difficult to perform in recent years, mainly due to the huge variety of operating systems, devices, browsers, and screen resolutions that applications are expected to run on. So in this slide, you can see an example of a visual bug that we found in a Microsoft Azure management portal. You can see here that the graph exceeded the expected bounds of the page. Here's another example from the Financial Times, and you can see here that the article title overflowed and hid and on top of the article body. And in this case, you can see that the top bar shifted downwards and doesn't appear where it's supposed to appear in IE8, while it looks right on IE11. So I'm sure that you're all familiar with this type of bugs and you see them everywhere. And you also understand the severity of these bugs. They could be very embarrassing and hurt the company brand, but beyond that, it could also completely cripple the functionality of an application and cost a lot of money. So just imagine for example, an e-commerce site where the product catalog is corrupted or the checkout or purchase button is missing. So why should you automate your visual tests? There are many reasons, but the most important one is that the test matrix is just too big to cover manually. Well, think of all the different web browsers, devices, operating system, and screen resolutions that your application is expected to run on. We all know that if a website looks good on IE, doesn't mean that it would look good on Chrome, or if an application looks good on a widescreen, it doesn't mean that it would look good on a smartphone. So we actually have to check and test that our application looks right in all of these different execution environments. If our application is also responsive, and most applications and websites are, then we also need to take into account all the different layout modes and test them in all these different execution environments. And if our website or application is also localized, then we also have to factor in the different fonts, resources, images, and content that are unique to each language and tested on each of these environments. So as you can see, the test matrix is huge, and it's just impossible to manually cover it in a repeatable and reliable manner. What makes things even worse is the trend in the recent years to keep shortening the release cycles. The recent hype, continuous deployment, dictates that whenever a developer commits a line of code, it triggers an automated process that results with that line of code being pushed to production. Companies that are doing continuous deployment are releasing code to production several times a day, and with such short release cycles, there is hardly any time to do any type of manual testing, let alone making sure that your application looks right in so many execution environments. When we're talking about native and hybrid mobile apps, then it gets even more difficult because it's much harder to roll back changes. If you have a bug in your system, you have to stay with it with production for a while. The reason is that you just cannot push daily to the App Store, and even if you manage to work around that, updates will take battery and data and eventually upset your customers and reflect badly on your app. And in general, there's a much higher quality bar for mobile apps just because mobile users are much less tolerant to UI and UX bugs. So how does a visual test automation tool work? So the workflow is very simple and consists of 4 steps. In the first step, you drive the application under test and take screenshots. In the second step, the tool takes those screenshots and compares them with baseline images. These baseline images define the expected appearance of the application. These could be screenshots that were taken in the past and were approved by a human tester, or they could be images that were taken at the same time only from a trusted execution environment. So, for example, a very common way to do visual testing is to validate your staging environment when compared to your production environment, because you assume that your production environment is bug-free. What you do is that you run the test simultaneously on both environments. You take the screenshot from your production environment and use it as a baseline to validate the screenshots from your staging environment and make sure that there are no unexpected changes there. In the third step of the workflow, the tool gathers all those screenshots and baseline images and the differences that it found, and it generates a report that makes it very easy to detect those differences and analyze them. And in the fourth step, a human tester, has to look at the report. If there were any changes, he decides for each change whether it is a bug, in which case he opens a bug, or if the change is due to a valid change of the application because we just released a new version, then the tester approves the new screenshot to be used as a baseline for subsequent runs. And of course, on the first time you run a test, you still don't have a baseline, so in that case, the tester just looks at the screenshots, approves them, and then you have a baseline that you can use for subsequent runs. So at this point, I'll hand it over to Joe. The controls to Joe will give you the sneak preview of LeanFT and also show you how to run visual tests with LeanFT and Applitools eyes.
Awesome. Thank you, Adam. So the first thing you might be asking is, what is LeanFT? So LeanFT is a brand new tool by HP that was developed basically to meet the automation demands of things like continuous integration testing and DevOps. And really what's cool about LeanFT is that it fits into the developer's ecosystem. So you can use basically the same tools that your developers use to create automation scripts. So, LeanFT supports Visual Studio, Eclipse, C#, and it supports unit testing frameworks like JUnit and NUnit. And it also supports version control systems like Git. Also, what's really cool is that you can have the added benefit of accessing HP's Windows-based technologies that Selenium doesn't provide. So in one framework, you can create an end-to-end workflow that deals with web applications and thick client applications all within one script. So that's kind of cool. So for this demo, I'm basically going to be showing us navigating to this web page, doing a visual validation check on this page, then clicking on resources, and then doing another visual validation on the next page. All right, so I'm just going to jump into the script and show you how to get started with LeanFT. So the first thing is once you install LeanFT, when you go to File, New, under Projects, you're going to have new options underneath your templates. And the two that we're really interested in are the LeanFT MS Test Project and the LeanFT NUnit. So for this demo, I'll be using MS Test. And when you select one of these templates, automatically it's going to generate all the annotations you need to get started with that framework. So the first thing you want to do is you need to specify what technology you want to test. So right now, this demo, I'm just using web, but you can also include the SDK for WinForms, WPF, SAP, standard Windows. But right now, I'm just going to do standard web. So once you have your import statement, you're then able to access the methods and all the different functionality of LeanFT. So the first thing I'm going to do under my test method on line 28 is I'm going to create a browser. And this browser is going to hold an instance of the browser that's pointing to Firefox. So if you want to test a different browser, all you need to do, because it's tied into the IDE, you have the IntelliSense. You could select a valid browser that you want to test against. But right now, I'm just going to go with, let's go with Firefox. All right, so once you have the browser specified, you then have access to all the methods of that particular object. So if you type in browser and do dot, I know my screen is kind of small, but this shows all the methods you can perform on a browser. And if you used QTP or UFT before, this should be very similar to, it's basically the same methods that you're comfortable with already. So I'm just going to do a browser navigate. I'm just going to navigate to that page. And so another feature that you have when you use LeanFT is you have access to this Object Identification Center. So I just want to show you really quick how to use that. So what I want to do in this test, I want to click on this resources link. So to do that, I have the SPY running, and all I need to do is point on the element that I want to interact with. And let me zoom in here. And basically, it's going to show you all the properties that are available to you, and it's going to make recommendations on what properties to use in order to uniquely identify that object. So right here, it has stars next to inner text, tag name, and index. So I'm just going to select those options. And it also has an option to highlight it to make sure that it actually finds the element that you expect, and then you can copy that. So I'm copying that, and I'm going to close this and go back to my project. And so once you have that specified, the test object, all you need to do is go in and just paste it in. So if you could see my existing test, it shows the properties that I want to use to identify that object. And what I'm doing here is I'm just specifying a variable to hold an instance of that test object of link type. And once you have that, once again, you can then access all the methods of the link object. So right here, I'm just doing a link exist. And if it exists, it's just returning true or false. And if it's true, I'm just writing out to the reporter that it passed. And if it fails, I'm just writing to the reporter that it fails. So once again, if you're used to UFT or QTP, this should be familiar to you, the syntax. And then I'm just closing the browser. So let's just run the test and take a look at what the results look like. So I'm just going to run the test. Awesome. So it passed. So you can see within Visual Studio that it shows a pass status. And if we take a look at the results, you can see the new LeanFT HTML reporter. So I'm going to go into the results. And once again, if you're used to UFT or QTP, this reporter should seem pretty similar to what you're already used to. On the left-hand side, it shows you all the objects that you interacted with and what type of actions you performed on them. And then if you click on one of these actions, it'll give you more information underneath the details information. And you can see that it passed, none errored, and there was no warnings. Cool. So that's how you create a simple LeanFT test. And what I want to show now is how easy it is then to run it against a different browser. All you really need to do is just specify the browser that you want to run against. So we wrote this against Firefox. Now I just want to run it against Chrome, and I'm just going to run it. You don't have to make any other modifications. And basically, it's going to do the same thing. It's going to start up Chrome, navigate to our website, click on the resources link. Awesome. So it passed. So if I zoom in on the pass status, you see that it passed. And I don't know if I specified this is C#, so I'm using just straight up Visual Studio using C#, and all I did was import the LeanFT API, and then I'm able to write up my code just like a developer would with any other object or any other library. All right, so now what I want to show is how to fix this script so we can actually add in visual automation, visual validation testing. So I'm going to head on over to my script that I have already for visual validation and go by that step by step of what it's doing. All right, so in order to get started with Applitools, the very first thing you're going to want to do is you're going to want to go in, and probably the easiest way to do this is use the Package Manager console and just install Applitools. And all you need to do is type in this command, install package eyes.leanft. And once you have that specified, you're then able to access the Applitools SDK. Once the SDK is in your project, like I said, this is the same exact script that I had previously, but I'm just going to modify it now to use Applitools. So really the first thing you just need to use is initialize the eyes object on line 27. And basically this eyes is the main object in the Applitools SDK. Once you have an eyes of type eyes object, you can then use all the methods that are available to you within Applitools. First thing you want to do is set your API key. You can either hard code it within your script, or you could do what I've done here. I just put it in my app config file. It just makes it more maintainable going forward. Once you have your API key set, I'm doing a baseline.name. I've already run the script before, and we'll see this later. I actually have the baseline already in Applitools, and so I gave it a name called LeanFT Web. So any scripts, any tests that I run here, it's going to compare against that baseline that's named LeanFT Web. And I'm also doing a force page screenshot. Now, this is kind of interesting. This stitches a web page, so it basically creates a full page screenshot, even if the whole page is not shown in the visible browser area. That's a big, that's something unique to Applitools. And you'll see that once again, once we go into Applitools, you'll see the whole screen once it does the stitching. And I'm setting the match level, and this match level basically is doing exactly what it says it's doing. It's ignoring any content changes, and it detects only layout changes. And this is really important if you're running a test against a dynamic website. Like if I ran against my blog, I really want to make sure my main anchor points and elements are there, but I may not care about, I have a new post and the post is different than what was there yesterday. I really don't care about that. So that's what the layout is doing. And then the next thing we're doing is going to start doing an open method. And that open method, all we're doing is going to pass it an instance of our browser. So I named it browser. And the other parameters are the name of the application under test, the name of our test, which I called HP LeanFT, and the size of the browser that you want to start up. And then here's really where the magic happens, is on line 38, this check window. So basically, the check window is the Applitools visual validation checkpoint. And this check window command basically will take a snapshot of the current window, and then it will perform a smart visual comparison of that window within our baseline. So it'll compare what appears in our test against our baseline. And so if you've ever used a traditional functional testing to do this, you'd have to write a ton of assertions. And if you don't assert it, it doesn't get tested. This is actually a lot different. This actually tests everything on your screen, and it's kind of crazy. You don't have to explicitly state anything. It will know basically the algorithm that there was a change that a user would notice, and it will flag you on it. Well, you haven't to explicitly tell it to. And also with other visual tools that you may use, a lot of times if there's a pixel change, that's going to cause a lot of false positives. With the eyes Applitools, it's smart enough to know to focus on only the changes that a human can see. So that's really going to reduce a lot of failures if you have done this in the past and not used a tool like this. All right, so we're just doing the same exact commands that we did previously. We're going to click on that link. And once I click on the link, I'm doing another check window for the resources, and then I'm going to close the browser and close the eyes. So let's just run this and take a look and see what that looks like. So the only difference here really is it's going to go in, and you'll see that the browser is going to move up and down. That's doing the stitching that I showed you. So it's going to make, even though the full page is not shown to us on the screen, when we look at it within Applitools, it captures the whole thing in one image, which is kind of cool. And then it's going to click on the resources and do the same for the resources page. It's going to do that stitching for you. And then it's going to compare the result against our baseline within Applitools. All right, cool. It passed, so let's take a look. So let's see what that actually looks like within Applitools itself. So I'm going to navigate into Applitools. And so I'm going to look at my tests. It keeps a run history of all your tests within Applitools and within the server. And so this is the one I just ran. It passed. And if I click on it, I can actually see the baselines that were captured. So there are two check windows. I have a check window for the first screen, and I have a check window for the second screen. Here are the screenshots that were captured during runtime, and you can compare it against the baseline that was captured. Now, what's interesting here is another time saver is we ran this test against Chrome, right? And it took a test, it took a baseline, but our baseline is against Firefox. So it's comparing Firefox against Chrome. And if you've ever done that type of testing before, you notice there's usually little differences, like if we toggle back and forth between the two. There's slight differences where the fonts might be different or the paragraphs might be slightly different, but it's really not a big change. It's not a big enough change. It's not a real change that a user would notice. So if we toggle back and forth, I'm not sure if you can see it on my screen, but you can kind of see the paragraphs jumping around a little, but the layout itself hasn't changed. So that's what we're doing. We're testing the layout. And what's great about this, if you used another tool that wasn't Applitools, if a pixel or any of these changes would cause a false positive test, and you'll have a bunch of failures that aren't real failures. So this algorithm is really neat that it's able to know what you're actually looking for to see if there's an actual change in your app that you need to know about. And so let's actually see what a change in your application would look like within Applitools. So I'm going to use the same exact test, but I'm going to use this JavaScript that's basically going to go to the resources page, and it's going to move that resources title 100 pixels to the right. So it's going to go capture that screenshot, compare it against the baseline, and go, oh, wait a minute, this is a layout change. This is completely different than what I expect, and it'll highlight the differences. So let's just run this test again and see what that looks like. Once again, it's doing exactly the same thing that it's been doing, except you'll see it when it gets to the resources page. It's going to move that title 100 pixels to the right. And this is just for a demonstration purpose to show you what a test looks like when it actually fails and how Applitools handles it. So once again, it's doing the stitching. And all this information is being stored on the Applitools server. So it keeps a runtime history of all your runs, and you can always go back and take a look at them. All right, awesome. This failed, and we expected it to fail. So if we take a look here, you see that it failed. And if you click on the test method, what's cool is Applitools also integrates with the Visual Studio so that it has a direct URL within there that you can click on and go directly to the failure within your script. So if we click on this URL, it'll bring us to the failure. And the failure is going to be highlighted in this pink kind of color. And you can see if we compare it to the baseline, that it's a true change to the layout, right? This is huge because all the visual tests before, if you run them, even a small pixel change is going to create a failure. This is actually noticing huge changes that are actually a change in the layout, and it highlights it in yellow, not yellow, in this purple pink color. And you can also use the radar to discover where it's located. You can do a whole bunch of other things within here. You can ignore things. You can exclude regions. There's a bunch of other things you can do, but the main takeaway is that, for me, is rather than do a bunch of assertions where you have to explicitly state every assertion for everything, you just do this one check window. It checks the window for you, and it'll catch things that you may not even thought about. So it's just a big time saver, and that's my demo. So I don't know, Adam, I think you have other more advanced things you want to talk about now?
Yeah, thanks, Joe. I'll take over from here. Wow, LeanFT looks awesome, I must say.
Yep.
And let me take it over for a second. Okay. Okay, so Joe, in Joe's demo, Joe focused on the first two steps of the workflow. Let's take a closer look on how you can view and analyze test results and how you update your baselines. Right now on my screen, you can see the results of running a visual test on my Gmail account. On the left-hand side, you can see the baseline image, and on the right-hand side, you can see the screenshots that we're validating. And as Joe mentioned, the differences are highlighted in pink. We also have this radar button here that allows us to highlight those differences so we won't miss out the small ones. So let's take a closer look at the differences and see what we found. So first of all, you can see that we found a typo in the More button. You can see that the Google logo has moved, and you can see that the search button changed color from blue to green. Now, there are a few important things to notice at this point. The first is that, as you can see, the tool finds visual differences that you would not expect your traditional automation tools to find. You would usually rely on human manual testers to find this type of bugs. The second thing to notice is, as Joe mentioned, each validation point actually captures the entire screen, including the hundreds of UI elements that are there. And actually, in this validation point, you get a lot of coverage while saving you from writing and maintaining hundreds of lines of equivalent test code that you would otherwise had to write. When comparing images with Applitools eyes, you can choose from a variety of matching levels. Joe talked a little bit about layout. I'll talk about layout in a bit more depth soon. But one of the other very important match levels is strict. And strict, as the name implies, performs a very strict matching of the pages. It can find minute changes on very, very large pages, stuff like a minus symbol changing to a plus symbol or a comma changing to a period. But on the other hand, it's capable of identifying and ignoring huge pixel changes that are completely invisible to the human eye. And there are many, many reasons for these differences to occur all the time. One of them, for as an example, happens on every web page where you have a table. So it's very common for one of the columns in that table to render and be 1 pixel wider. And when that happens, the rest of the columns just shift 1 pixel to the right, and this can create a huge pixel-wise difference in the images. It could be 70 or 80% difference as far as the pixels are concerned, but we as humans we do not see this change at all, and even if we could see it, it's just 1 pixel, so no one would care. And the strict matching algorithms can detect that this is something that we cannot see or don't care about, and so it will not flag it as a different, and this goes a long way in keeping your tests very stable and allowing you to get to very large scale with your visual tests. So another important thing about strict matching is that you don't need to configure it at all. You don't need to specify a tolerance or threshold whatsoever. If a human can see the difference, it gets flagged. If he cannot see it, it is just ignored. When working with strict matching, it's very important to be able to deal with dynamic data on the page. So for example, when I'm running this test on my Gmail account, every time I run it, I get a different ad. And I don't want that to fail my tests. So it's very easy to ignore these parts that are dynamic by placing an ignore region on top of them. You don't need to write code. You just need to go and mark these areas so they would be ignored, and the image matching engine will now not compare these parts, and so no differences will be reported here. Similarly, if you have moving elements on your page, such as this Google logo, maybe they're animated, perhaps they are attached to a different element that changes size, so it's very easy to mark them as floating regions. When you mark a moving region as a floating region, the tool automatically detects the range in which it is moving, and you can also adjust it to the full range. And the meaning of a floating region is that as long as the Google logo appears the way it should inside this blue area, then the change will be ignored. But if the Google logo changes or appear elsewhere on the page, then this flag will not be ignored, and this change will not be ignored, and the test will fail. The next match level that I want to show you is layout. And with layout matching, we only care about layout changes between the baseline image and the screenshot. So in this example, the only difference that counts is the Google logo that is moving. The fact that we have a typo here or the fact that the color change does not affect the layout of the page, and so it is ignored. Actually, even if we remove the ignore region from the ad here, you can see that still it's not marked as a difference, because although the ad is different, as far as the structure of the page is concerned, the structure is still consistent. So this is one very good reason to use layout matching, and that's in the cases where you have very dynamic pages to validate. Let's take a look at a few more examples. So in this case, we are looking at the Yahoo homepage, which is a very dynamic page, and the screenshots was taken in a 24 hours difference from the baseline image. And so, as you would expect, the images are different, and the articles here are different. But then again, as far as the layout is concerned, the pages are consistent, and because of that, no differences are reported. If I would switch to strict matching, then you can see that all the dynamic parts are highlighted, but the fixed ones aren't, okay? And that's the way that strict works and how you would expect it. Just to show you how powerful strict is, if I would change this to exact pixel matching, you can see that everything is highlighted here. And the reason is that actually all the pixels on between these two images are different, only that we as humans cannot see that, and strict knows how to ignore those parts that we don't see. Another reason to use layout matching is to do cross-browser validation, just like Joe showed you on his demo. So in this case, we have a website where the baseline is in Chrome, and the screenshot was taken on IE. And if we toggle between them, you can see that, as you would expect, IE and Chrome render stuff differently. So you have slightly different font sizes and positions, and the scroll bar is different, and the text here reps different in this paragraph. But as far as the layout is concerned, the pages are consistent, the images are consistent, except for this element here, which is missing in IE. So you can see how powerful layout matching can be to detect layout violation, which are actually very important bugs. As a final example, I want to show you how to do cross-device testing. So in this case, we have a website where the baseline is in Chrome, and the screenshot was taken on IE. And if we toggle between them, you can see that, as you would expect, IE and Chrome render stuff differently. So you have slightly different font sizes and positions, and the text here reps different in this paragraph. But as far as the layout is concerned, the pages are consistent, the images are consistent, except for this element here, which is missing in IE. So you can see how powerful layout matching can be to detect layout violation, which are actually very important bugs. As a final example, I want to show you how to do cross-device testing. So in this case, we Twitter on two different mobile devices, Samsung S4 and Samsung S5. Again, Twitter is a very dynamic application, but you can see that the baseline here dictates that the paragraph will be aligned to the left and to the right of the image, and this is being violated in the screenshot, and because of that, the change is highlighted. Similarly, we don't have an image here, but we do have one in the baseline, and that's why it's highlighted. As you can see, layout matching actually captured all these differences, although we are doing cross-device visual testing on a very dynamic application. Now let's go back to the first test, and I'll show you how to update the baseline. So in this test, as you can see at the bottom, we have a timeline that shows us that we had 4 validation points or 4 check windows in our test. And the first one is green, which indicates that no differences were found at this checkpoint, but the rest of them are red, indicating the differences were found. And although the screenshots are different on each validation point, it's the same 3 differences that we've seen before: the Google logo moving, the typo on the More button, and the search button changing color. So if I would like to use this new screenshot as the baseline for subsequent run for this validation point, all I have to do is just click this accept button. But when I do that, the tool automatically analyzes all the remaining changes, and it found that they're exactly the same change, so it approved it automatically for us, and it is completely accurate. I don't even have to look at them anymore. So this type of automated maintenance can save you a huge amount of time maintaining your baselines when you have thousands of tests that are run each day. And just to give you an example of how this is useful, just imagine that you have a website and you have 1,000 validation points on that website, and you've just changed the header of the website. So with automated maintenance, you only need to accept the difference in the header just once in one of the validation points, and the tool will automatically approve all the other screenshots. You won't have to look at all of them and approve them. And this operation is completely safe, meaning that if in some validation points there were other differences in addition to the header being changed, then the tool will not automatically accept that, and it will immediately move you to that specific validation point, so you will decide what to do with it. Another form of automated maintenance that we have in the tool has to do with those ignore and floating regions. So for instance, if I decide that I want to ignore this element here in the 4th step, and I move to the 2nd step, you can see that the ignore region ended up here as well. And if I decide that it should be wider in the 2nd step and I move to the 1st step, then you can see that it is wide here as well. But if I move to the 3rd step, where the element does not exist, then of course the region was not added in the first place. So the application is full of these little features that really allow you to be very effective and avoid repetitive work when you update your baselines. So now let's continue and explain where and how automated visual testing fits in your testing life cycle. And the short answer is that it fits in each of the stages. At the unit test level, it's very common for front-end developers to perform visual unit tests on their UI components that are built. They are able to make sure that the components appear right in all the different browsers, and they can also make sure, it's even more important, that when they change the code or the CSS files, etc., it only affects the components that they intended to affect, and it does not ruin the other components in any way. At the integration testing level, Joe already showed you how easy it is to take an existing end-to-end test. In Joe's demo, it was with LeanFT, and turn it into a visual test by adding just a few lines of code, just those check window statements. Then you could easily perform end-to-end visual validation of entire pages of your website or application and get a huge amount of coverage. You also get a very nice bonus because the dashboard of Applitools becomes a very powerful collaboration tool, because suddenly you have a central place that consists of all the changes that happened in the application since the test last ran. So if you have a CI system that's running tests every 2 hours, then a product manager or a project manager can check that dashboard every now and then. If any changes were detected in the last 2 hours or 4 hours or since the last time he checked, he can immediately zoom in on those changes and provide immediate feedback to the developers on the changes that he saw. He doesn't have to wait for the sprint to end or for another 2 months when he'll accidentally stumble upon the change in production. At the acceptance testing stage, it's very common to validate the staging environment against the production deployment. We've already discussed that when we talked about the workflow. And there are many companies that are doing visual testing as a monitoring activity on their production deployments, and this is very useful to identify, to make sure that there are no missing resources in the production deployment. If your application shows and consumes third-party data, you can make sure that UI does not get corrupted due to that data, and it's a very good way to identify corruptions due to browser and OS upgrades. So for example, Chrome updates very frequently and you can't do anything about it, but when Chrome updates, it can add new functionality, change existing functionality, and even introduce new bugs that can cause corruptions on your site without you having to change a line of code. So by monitoring your production environment, you can immediately identify when that happens and be notified and immediately deliver a fix. So at this point, I'll hand it over to Yaniv, who will tell you about HP Live Network.
Adam, can you, yeah. Hi everyone, my name is Yaniv. I'm the R&D manager and product manager for HP Live Network, also known as HP LeanFT. HP LeanFT is HP software content marketplace, which could be found at hpleanhp.com. Now, when I refer to content, I'm referring to a gap, and that gap exists for you as a developer, as testers, as very technical persons who use HP software product, and this is addressing the gap that that exists between what we provided, in this case LeanFT, and what you really need. And it was a great presentation made by both Adam and Joe. Very interesting to see that. And this is exactly the gap we are trying to address. But we are not doing that only for LeanFT. HP LeanFT is a one-stop shop for 70 products of HP software, and we provide over 500 different content offerings, and our sole purpose in this case is to increase your ROI from HP software products. So if you are an HP software product owner, customer, end user, I encourage you to go into each HP LeanFT, and again, this is it could be found at hpleanhp.com, and browse through the 70 products that exist there. Where is that? What is the announcement that were made? Where are the blogs, the best practices, and most important, where is the content? Where is the content catalog of that product? And when I say content, I refer to content that was created by HP software, content that was created by HP software partners like Applitools, and even by the community. There are several products that allow their customers to contribute back and share their best practices or their tweaks with the rest of the community, and get some credit for that. Now, when you go into a content offering, just like we see here for Applitools, you could learn about it. You see the description. You can see some videos around it, a screen capture, and you can download. Sometimes the download is a guide how to use it, or how to obtain it, or how to buy it. Sometimes it's the actual content, the actual executable plugin add-on that is being distributed there. And sometimes it's also being sold. There are several partners who started selling content directly on HP Live Network. Now, just to give an example of some of the content that exists today on HP LN, we are talking about SAP Test Automation Accelerator for UFT, scriptless test automation framework for UFT, custom tools bar for load runner, different correlation rules, adding content for ALM, application life management, and more and more. But the content is not limited only for the testing suite of HP software product. It's also available for the IT operation management product. So if you are a customer of BSM, Cloud and Automation, or SPM product, you'll find a lot of content for that here too. For more information, I really encourage you to go into HP Live Network at hplnhp.com. If you want to be a partner or contribute content to the community, you can contact us at the HPLN Partners Program. If you face any problem, whether it's operational problems such as login items, entitlement, or any other question, send your question to livenetops@hp.com or directly to me, yaniv.bigger@hp.com. With that, I want to thank you for the opportunity to expose HPLN here. It's been a pleasure and a very interesting demo by Adam and Joe. Thank
you, Yaniv. So let me grab the controls again. Okay, before we move to the questions and answers part, we have a special offer to all webinar attendees. Just send an email to sales@applitools.com with the coupon code LeanFT157, and you'll get 1 free month of unlimited enterprise plan, which means that you can run as many tests as you want at any capacity, at any concurrency for free for 1 month. I hand it over to you. Please let us know which questions were raised during the talk.
Okay, so first of all, Adam, Joe, Yaniv, thank you for this very insightful webinar. So we move on to questions. So we have a few for each of you. We'll actually start with Yaniv from HP. They're asking if LeanFT is available for download now, and if yes, could you please share a link or tell us how you can get to it?
Adi, I can barely hear you. Could you repeat that?
Yeah, sure. People are asking if LeanFT is already available for download, and if so, how to get it, and if not, if you can provide some more details on release schedule.
LeanFT is available at a different portal. This is the sas.hp.com. I suggest following up at that place. So again, it is sas.hp.com.
Okay, great. Now we have a question for Joe. So we have, I'm just bringing it up. People are asking about the new LeanFT. Are the technology supported same as available in current UFT and add-ins?
It's not one-to-one right now. There are support for, currently in the beta, I don't have the full version yet, is web. There's standard web, standard Windows, SAP, and standard and WPF. Those are the four that I'm aware of right now. But it's not a replacement for UFT. It's just another way that dev testers can integrate with their dev environments to create tests, but HP is not selling it as a replacement for UFT. So it doesn't include everything that UFT has.
Okay, great. So a question for Adam. Does Applitools work with more than web pages, browser applications, and the asking about desktop applications, mobile apps, etc.?
Okay, so basically, Applitools technology is completely based on image processing. So at the low level, all the image comparison engine cares about is screenshots, and we don't really care where they came from. So even if you took and painted an image with Photoshop, you can still use Applitools eyes to validate it. Having that said, we have close to 20 SDKs in multiple programming languages that allow you to hook into all the major test frameworks, such as QTP and LeanFT and Coded UI and Selenium in on the language bindings and Appium and others. And beyond that, we have SDKs that just work with images. So if you have an image file of a screenshot that you took from your own custom environment, you can still use the eyes object to just validate that specific image by reading it from the file system or providing the bytes of the image directly in code.
Okay, great. Thank you, Adam. Another question for you is what sort of data protection does Applitools offer? Get worried about time-quantum data Applitools servers. Could you answer that?
I couldn't hear you well. I think that perhaps when you are reading the questions, you are looking away from the mic. So if you can just repeat it, I didn't hear anything. Thanks.
Yeah, sure. There is an attendee asking about data protection on Applitools servers.
Yeah, so Applitools servers are hosted in the Azure data center, and it enjoys benefits from the very high level of security that is provided by Microsoft there. There are three ways to consume the service. The first one is the public cloud, when you have a very large cloud consisting of many servers that serve many customers, and there is full partitioning of the account, so no one can see the other customer's account. The other deployment that's possible is a private cloud, where you have a copy of that cloud that is dedicated to your own company. The benefits there is that you're the only one that has access to this machine, and you can also harden the security by restricting IP access or having your own dedicated VPN to these systems, and so you can make sure that only you are interacting with those machines. And the third option is to just a second. And the third option is to deploy Applitools eyes on-premise behind your firewall, and then, of course, no information comes out of your organization.
Okay, great. So one last question for Adam. That's also one for you. Does Applitools require precise or same resolution of browser window screenshots for validation against baselines?
So it depends on the match level that you're using. So of course, if you are using strict matching, then you do need the viewport size of the browser or the application size on your mobile device to be the same. And if you want to try it on different sizes to, for example, to test a responsive application, that you need to have a different baseline for each of these screen resolutions. It has nothing to do with the type of screen and the size of the screen that you are now connecting to. It only depends on the size of the application window or browser that you actually set when you run the test. The SDK, the IS SDK, automatically identifies the details of the environment that you're running on, so you don't need to change your code. Applitools automatically identifies the environment and create a specific baseline for it, and it automatically knows to which baseline images to compare your screenshots based on the environment where you're running the test. Now, when you're working with layout matching, then you can have different browsers, you can have different browser sizes as long as you maintain the same layout. So if you have a responsive application that has like 3 layout modes, then you need just a baseline for each of the layout modes, but when you have a baseline for a certain layout mode, you can use it to validate different screen sizes of the same layout mode.
Great. So we have one last update from Yaniv from HP. Yaniv, you wanted to update us about?
Yeah. So LeanFT will be released tomorrow together with UFT 12.5. It will be available at sashp.com, as I mentioned, and also through hp.com/go/LeanFT. And right now it's going to be free for UFT users. Today it's still a registration page, but it's going to be available starting tomorrow.
Congratulations, Yaniv.
Thanks.
Awesome.
Okay, great. So this wraps up our webinar today. Thank you so much for joining us. The event was recorded, and we will send you a link to the recording once it's available online. I'm going to leave the session open for a few more minutes if you have additional questions to ask. As I promised, we're going to get to all of them and send you an answer via email. So thank you again, and thank you to our wonderful hosts, Adam, Joe, Yaniv. Thank you very much.
Thank you, Adi.
Bye-bye.
Thanks.
Bye, everyone.